All right, so if you're a Swift developer, you've probably wrestled with this. How do we write code that's super flexible and reusable? Well, Swift gives us two pretty powerful tools to get the job done. And today, we're going to put them head to head in a little showdown: protocol types versus generic constraints.
So the big question is, which one's best? Is there a clear winner here? When should you reach for one over the other? Well, let's dive in and figure it out.
All right, let's meet our contenders. In one corner, we've got protocol types. And in the other corner, generic constraints. These are the two heavyweights battling it out for the title of best tool for flexibility. And trust me, they each bring a totally different game plan to the ring.
Okay, so first up, let's set the stage. What's the actual goal here? It's all about writing code that isn't locked down, right? We want to build things that can work with lots of different types, not just one single super specific structure class.
All right, let's bring out our first contender, protocol types. You can think of this one as the master of mixed collections. Seriously, it's brilliant at handling a whole bunch of different but kind of related things all together in one place. Now, if you remember one thing about protocol types, make it this. A variable of a protocol type can hold any value, as long as that value conforms to the protocol. It's kind of like having a magic box. You can put anything you want in it as long as it has a certain sticker on it. That's its real superpower.
So let's see this in action with a super common example. We'll start by creating a shape protocol. Think of this like a contract. It basically says, hey, if you want to be considered a shape, you have to tell me how to calculate your area. Then we create two totally different types, a circle and a square, and both of them sign on the dotted line, agreeing to that contract.
And this is where the magic happens. We can now create one single array, an array of shape, and just drop a circle and a square right into it, side by side. Even though they are fundamentally different types, they get to hang out in the same collection. Why? Because they both signed that shape contract. So there you have it. Protocol types are amazing for creating these flexible, mixed-up collections. But there's always a but, right? The trade-off here is a little bit of performance. See, when the code is running, it has to look at each item in the array and figure out, okay, is this a circle or a square before it can call the right area method? That little lookup is called dynamic dispatch, and it just means there's a tiny bit of extra work happening behind the scenes. Okay, time to bring in our second contender. This one has a completely different strategy. Let's meet generic constraints, the champion of compile time safety and pure, unadulterated speed. This is the one that likes to know everything up front.
Now listen closely, because the wording here is super important and really subtle. This isn't about storing just any old value in a collection. It's about creating a function or a type that can work with any single specific type, as long as it conforms to the protocol. The whole focus shifts from the container to the action.
And this is what it looks like in practice. We make a function, let's call it print area. See that little T shape part? That's the secret sauce. T is just a placeholder. It's like saying to the compiler, hey, I'm going to give you some type. I'll call it T for now, and I promise you, whatever T is, it will be a shape. So we only have to write the function once. So check this out. When we go to use that function, we call the exact same print area function for both our circle and our square. But here's the critical difference. The compiler is so smart, it knows exactly what's going on at compile time. It sees the first call and says, okay, for this one, T is a circle. It sees the second and says, yep, this time, T is a square. There is zero guesswork. And that leads us straight to the killer feature of generics, performance. Because the compiler already knows the exact type, it uses something called static dispatch. Remember that little runtime lookup we talked about before? Gone. The compiler just connects the dots directly, making the code way faster and opening the door for all sorts of cool optimizations. All right, the introductions are over. We've seen what both contenders can do. Now it's time for the main event, the head-to-head comparison. Let's put these two side by side and really see how they stack up against each other. Okay, so this table really lays it all out. When does the compiler know the type? For protocol types, nope, not until runtime. For generics, absolutely, it knows right away. That leads directly to the dispatch type, dynamic versus static. And that, of course, affects performance. Generics are just plain faster. But, and this is a huge but, what about storing different types together in one collection? Only protocol types can do that. That is their knockout punch, their undisputed superpower. So, after seeing all that, you're probably realizing this isn't really a story about one being better than the other. It's not that simple. It's really about choosing the right champion for the right fight. It's about knowing you've got two incredible tools in your toolbox and knowing exactly when to pull each one out.
So let's boil it all down to a simple rule of thumb. When do you use each? Well, if you need to put a bunch of different but related things into a single collection, like an array of various shapes, you're going to reach for protocol types. But if you're writing a function that needs to be super fast and type safe, and it operates on one of those shapes at a time, that's a job for generic constraints. It's as simple as that. So now you know the difference, you see the trade-offs. The next time you're staring at your code, trying to make it more flexible, which tool are you going to reach for? Because knowing when to use a protocol type and when to use a generic constraint, that's what separates good code from truly great, elegant Swift code.